Hello there and welcome back here on Fundo Academy. We are continuing with our mathematics revision course. Now we are talking about rational and irrational numbers. Okay, so we want to start with rational numbers. So what is a rational number? Okay, so you need to know that rational numbers are numbers that can be expressed as an exact ratio of integers. So all numbers that can be expressed as an exact ratio of integers are rational numbers. In other words, we are saying that rational numbers can be expressed in the form a over b, where a and b are integers. Right? So any number that can be expressed in the form a over b, where a and b are integers, as simple as that, is a rational number. So examples of rational numbers include a number randomly. I'm just taking numbers that are rational numbers. A number like 8 is a rational number. What makes 8 a rational number? Because according to our definition, these are numbers that can be expressed in the form a over b, where a and b are integers. So 8 is actually 8 over 1. And 8 and 1 are integers, so that makes 8 a rational number. Another example of a rational number is 0.5. You know that 0.5 is a half, is 1 over 2, so it's also a rational number. So decimals like that are rational numbers. A number like the square root of 9 is also a rational number, because square root of 9 is actually 3, and 3 is 3 over 1, so that makes the square root of 9 a rational number, since 3 and 1 are integers. Okay, another rational number is the fraction 1 over 2, which is just the same as 0.5. okay, so that's what we call rational numbers. And maybe for you to understand better, also we have a percentage is also a rational number. Remember, if we have like 12%, that's like 12 over 100, right? So percentages like 12% are also rational numbers. In fact, all percentages are rational. Okay, so let's look at irrational numbers. Maybe if we learn what irrational numbers are, we can understand better what rational numbers are. So with irrational numbers, they are different or opposite to rational numbers, because with irrational numbers we are saying that these are numbers which cannot be expressed in the form a over b, right, where a and b are integers. So that's the key thing here, they cannot be expressed in the form a over b, where a and b are integers. So examples of such numbers include the value of pi. We use pi a lot, especially when dealing with circular measure, like the area of a circle, remember, is pi r squared. So we have the value of pi. If you punch that value in your calculator, you're gonna find it coming out something like this: 3.14159, and it continues to go, you know. And actually this value of pi continues to go, extending itself unto infinity and never terminating. So we call this an irrational number. We cannot express it as an exact ratio or in the form a over b, where a and b are integers. So such a value like pi is an example of an irrational number, right? So the way we deal with irrational numbers is we round them off to give to significant a certain number of significant figures or decimal places. For example, most of the time you find the value of pi being given as 3.14 or something like that. So that is how we deal with irrational number. Another example of an irrational number is the square root of 3. The square root of 3, if you punch it in your calculator, or if you look for it in your tables, it will come out something like 1.73205. In your calculator, it continues to go right to the end of the screen, and this also does not terminate. It continues to go on to infinity, like that. So it's also another example of an irrational number, square root of 3. It cannot be expressed in the form a over b by any way, where a and b are integers. Alright, so such an irrational number like the square root of 3 has a special name. We call such an irrational number, we call it a surd. So surds are irrational numbers expressed in the form of a square root, like that. So when we have like square root of 3, it's an example of a surd. Square root of 2 is another example of a surd. Square root of 9 is not a surd. Why? Because this can be expressed, can be simplified to give us 3. So the square root of 9 is not an irrational number, it's not a surd. But square root of 2, you see such values, if you punch them in your calculator, you're gonna find them giving us non-terminating decimals which continue unto infinity. So these are what we call surds, irrational numbers. So in the next lessons we're going to be dealing mainly with surds, irrational numbers called surds, in solving problems, and we'll also learn how to manipulate surds, talking about addition, subtraction, and simplifying them.